Okay.
This conference will now be recorded.
I always forget to record the class. Okay, so we're recorded now, and we're talking about the constant displacement deceleration challenge that I'm putting out there to you. The two methods of doing this, oh, by the way, no encoder feedback makes it, somewhat more challenging, but the reality of it is that most of these applications are going to be no encoder feedback, and therefore A102 will be set to 2 or 5. I included 5 because we might be using a PM motor. Interestingly enough, I've not done a PM motor application, but in my mind it would be easier to get better accuracy with the PM because it's a synchronous motor. We don't have the slip, and therefore we don't have the variation in RPM based on loading. But with standard gearing, and all the backlash associated with that, which should be somewhere on the order of a couple hundred arc seconds, a few degrees, in a standard right angle worm gear, for example, the accuracies of plus or minus a quarter of an inch are quite achievable. Now, the two strategies that we're going to look at are modifying the decel time based on the velocity that we are running at when we cross the prox. If we're running at full speed, we'll obviously have to decel faster than we will run at half speed in order to cover the same distance, because we're starting at a faster speed, so we need to bleed off that speed faster to keep the distance constant. The math behind it is the challenge. There's another challenge in this DWES program, in that when I started to do this, Davey Peters informed me that it's very difficult just to work with whole numbers, because the whole DWES program is based on percentages. And this is where we come into one of the limitations of a high-order graphical user interface language, where you don't have full flexibility, and you have to create some workarounds to deal with those limitations. That is where the real challenge is going to be. The secondary challenge is coming up with the correct formula for the new deceleration rate. It's quite easy to tell the drive, C102 is your normal decel rate, which of course is the number of seconds from whatever the maximum speed of the motor is, and we'll assume 60 hertz for this discussion. The new deceleration rate will be based on C102 and some formula involving the velocity ratio, or VEL ratio as I'm going to call it. And that VEL ratio consists of a comparison between the maximum speed and the actual speed that we are running when we hit the prox. It's going to be necessary to constantly calculate that velocity ratio as we're running the conveyor and varying the speed, because in the program we really don't know when the prox is going to come up. So we need a VEL ratio value that we can use at any time, and at the time that we hit the prox. When the prox is hit, we remove the run command and we start the decel, and we refer the VFD to, say, C104, which is an alternate decel parameter that will be the result of our calculation of C102 and the VEL ratio. So the details are the challenge, and I've outlined them in this document. The second strategy that I came up with would be to delay the run off command. So when we hit the prox at full speed, we'll start decelerating. If we hit the prox at some speed less than full speed, we will delay the run off command, continue at the speed that we're at until we get to the correct point on the decel curve, and then decelerate. I'm not sure if that method will work, or it would work, but I'm not sure if we have the calculation capability in DWES to do that, and we're going to find that out. So what I've done here is I've outlined an application that is very challenging within the limitations of the DriveWorks Easy program. In the applications course that you take, and in the 8 videos that we've shown you so far in this class, we've only talked about pretty easy applications. My experience is that the vast majority of the applications you're going to come up with will involve certain challenges like this, where you're going to have to, as my colleague Danny Peters says, noodle around a little bit and scratch your left ear with your right hand in order to get the result that you want. This is a limitation of DriveWorks Easy. It is also, in my humble opinion, something you run into quite often in higher order graphical user interface languages. That's one of the reasons why really good programmers like to operate down at the lower level languages. They understand all the syntax and whatnot associated with writing in the lower level languages, but they also like the fact that there are less limitations, because the objects that we have here, we don't have an infinite number of objects, therefore we don't have an infinite number of capabilities. We have a subset of what is possible. So DriveWorks Easy, I think, tends to be more on the limited side of that spectrum because it is such an easy program to use. It is objects only. Now you can potentially write some of your own objects. That's a course well on down the road in this series. But for now, we're going to review a little bit of what we've gone over in the previous weeks, and then I'd like some of your feedback on this application. And I don't think I'm going to get a lot today, but I would like to see you participate and give me your ideas. Now, what I'm going to do here is I'm actually going to send an email. I don't normally send an email during the class. I'm going to call it the DriveWorks Easy Challenge, and I'm just going to send it out to you so you can review it while we're talking. Okay, hopefully you'll get that. Now, as a quick review of DriveWorks Easy, remember that there are 2 versions, the one you can download standard and the one that is the Pro, which you must take a class for, and it's a very easy class. You watch the 8 videos, which we've already shown you, and then you complete the test. And I'm going to put the test up right now. Hang on a second. Nope, it's not that one. Where did I put that? My apologies. There it is. Okay. So let me see if this works. Okay, so the certification test, basically, there's your answer sheet, and there are the questions. This test is pretty easy to take, and I highly recommend that you get the Pro version for the next couple of weeks of this class where we're going to be discussing specific applications. Now, is Kyle Klinger on? Kyle, can you hear me?
Yep, I'm here. What's up?
Hi, I wonder if you could take a minute, because I think you're probably one of the most experienced of this group in the DriveWorks EZ program, and tell us, say, the top 3 programs that you can remember doing with DriveWorks EZ.
Sure. It's funny, the biggest two that I wrote the most extensive code for were kind of similar in their functionality. One was for a testing unit for General Atomics, where they wanted to run a unit basically back and forth on a linear track, and it would accelerate. It was basically doing a trapezoidal move, and they had a slowdown sensor and a stop sensor at both ends, but there was no encoder feedback. So what I was basically doing was giving a run command. When the slow sensor triggered, it would ramp down and then to a crawl speed, and then it would crawl till it hit the end of limit switch, and then it would come back the other direction. And the whole reason DriveWorks EZ was used is because they wanted to do a set number of iterations. So via a little touch screen, they would, or no, via the Q parameters, they'd program in how many iterations they wanted to do, 100, 200, 300, and then just using SR switches, it would ramp up, ramp down, stop, reverse, ramp up, ramp down, stop, and it would do it for however many tests they wanted to do. And they would run it for, hundreds or thousands of tests every week, just switching out units. It was a test rig. Another one was a trash can stacker over at, I don't know the name of the customer, some trash can extruding company, and they wanted to stack the trash cans, and they had this automated machine. And before they needed a PLC to do it, and we came in and spec'd out and we got rid of the PLC and were able to do it with this DriveWorks EZ program, where basically it was a couple of sensors interacting with the operator. Would put a trash can in, it would pick the whole stack up and set it into the new trash can, and it was basically the same kind of functionality where it would run up to limits, run down to limits, but it would follow a certain sequence of operations with like grabber arms, and you're again able to do all that sequencing and logic in DriveWorks EZ. I've done a bunch of just similar kind of things where you have a little bit of logic where you need to like switch things based on a sensor input or a combination of sensor inputs, like the trash can has to be in position or an object has to be in a place before you're able to run. And then your run is conditional, so you want your run to go until it hits a limit or it goes to a sensor turns on, things like that, and then you turn the run command off. Is that good enough? You want me to keep going?
No, that's fine. I'll actually send you an email and talk to you about a couple of other things that I don't want to put you on the spot on right now. Did you ever work on an issue of dealing with whole numbers versus percentages in the DriveWorks EZ program?
Like converting, you mean?
Right. One of the challenges I ran into, and it took a little bit to solve, was the velocity ratio that I'm referring to in this constant displacement decel program, where everything in DriveWorks EZ is in percentages.
Right.
And I needed to calculate a ratio, a number, and then use that to modify the decel rate. And I found that to be, shall we say, less than intuitive.
I don't think, I've done it before where I set up constant ramp decels based on how far off of a position I was. So I know I've done it. Off the top of my head, I don't remember how. I'm on the road right now, otherwise I'd look up how I did it in my project. I think it has something to do with multiplying by constants using the percent constants to try to get it to where you need it to be. Or, you got the Q parameters too, so you can enter hard-coded values to get yourself where you need to be.
Okay. Well, I will take that offline and send you an email, and if you would,
sure,
and you have to give me some time, we can talk about that. I'd like to see what your method is. The method I came up with, I think, is a little kludgy, and I think it could be improved. So, thank you, Kyle. I appreciate that. The discussion goes back to now just reviewing where we are at, and again, the fact that this is a relatively easy test to take. It's an open book test, and I highly recommend that you take the test. This is the applications document that I sent out to you initially. It's also available on Yaskawa website. And I'm sorry for that light behind me. I'm going to black that out next time. I've been sort of constantly trying to put my head in front of it on the camera. So this application guide to DriveWorks Easy is the document I'm talking about. This will guide you through the course and allow you to take the test to get DriveWorks Easy Pro. Please go ahead and do that. Now, with regards to the actual program, let's just run a quick review today so that we kind of get back on our feet. And bring that over onto the screen. This was me noodling around initially, so I'm not going to delete the program, but I want to basically review with you the type of objects that we have and some of the other functionality associated with this. The first thing I would like to do is to go to Settings, and here is where you check for an update. I checked for an update this morning and nothing happened since the last time I was online. I have my version number here, and I can always obtain that information in the About DriveWorks Easy program. This is my user number. You can actually add some users to your program. I want to remind you that I'm not really sure I understand the reason. I don't understand much about what lawyers do, but the lawyer part of our program says that we tie the application to the primary user of the program, and you need to be careful about this when you put this onto a customer's machine. Because if you do it in your version, for example, I'd be doing it as 1, 2, 2, 4 zeros and a 3, I'm the only person from now until the second coming that will be able to modify that program. It's my program. It's tied to my version of DriveWorks Easy Pro. So when you do this, you may want to do it in the customer's version of DriveWorks Easy Pro so that he has control of his destiny, or his programmer does, not you. I'm speaking here to the distributor people that are on this class, and with respect to the OEM people that are on this class. As a distributor, you probably want to let the OEM own his own program on his own version of DriveWorks Easy Pro, and that's easy to do. You can develop it on your own and then just transfer the objects over to his version. So, small reminder there. To get out of this, get back to the program, save and close. Now, as you remember, there are various different types of objects that you can see here in the menu. Regardless of the type of object that you choose, there is always on the right hand side a definition of what that object is and how to use it briefly. This here confuses a lot of people. Use once. When it says no, it means that you can use this parameter several times in your program. When it says yes, it is a parameter that can only be used once in a program. And that's simply the definition. So, from the top of the list, we have our drive I/O, and by the way, each drive that possesses DriveWorks Easy, each drive model, GA500, GA800, will have slight differences in terms of the capability of DriveWorks Easy because the drives have different capabilities. Now, the biggest one is the number of objects you can use. You can use more objects in a program for GA800 than you can on the program for a GA500 or a P1000. And that has to do with the memory available on each of those drives and the processing capability. Also, each of those drives has slightly different number of I/O. For example, the GA800 has 8 digital inputs and 3 analog inputs, and that's not the same for the GA500 or the P1000, so you'll need to refer to each drive for those details. But I'm on a GA800, so it's going to show me the 3 analog inputs and the 8 analog outputs up to 16, actually up to 18 with a DI option card. That's odd. Why is that? I'm sorry. Digital input 1 through 8. It confused me for a second. Here are the optional. You can add another 8, so you can get a total of 16. Back to the standard I/O. We have the pulse inputs, the digital outputs. Now, bear in mind that on the GA800, on any of our applications or any of our drives, some of the outputs, the digital outputs, are relay, and some of them are open collector, or basically a transistor. So, we then have all of our drive monitors in this parameter set, and that is this one, for example, the motor speed would be the one that I would use to calculate Bell ratio in that advanced application we were discussing a few minutes ago. Just move this lamp a little bit out of the way. Similarly, drive commands. This is where we tell the drive to go forward and reverse. Whether we're in torque mode, whether we just the soft starter time, accel deceleration of the drive. Here are some alarms. DC injection. This is where we can inject DC into the motor for braking. These are all things that you're familiar with from reading the manual. Now, the keypad is an input device. It's our human-machine interface in DriveWorks EZ, and it allows us to get data from the user into the program. There are inputs and outputs. It can be used as a display. This is your logic section, and for example, this is a logic section that gives you a positive or high output if both of the inputs are high. That would be an and then of course an OR would be if either of them are high. And there are not versions of those. In other words, in the NAND, it would give you a low output if both of the inputs are high. It operates exactly in reverse of an AND. So NAND is not AND. Again, the digital functions are useful as we do more advanced programs. You have timers. Here's a one-shot. I'm going to use something like that in the constant displacement decel program to turn off the run command when I hit the procs. If you think about it, as we're running down a conveyor, we only see the procs momentarily, but we want to turn off the run command permanently. And since the procs input doesn't last, it's going to come in on, say, S8, the digital input S8. And then the DriveWorks EZ program will be monitoring S8 and will only see a pulse. Now, in the actual application, we'll need to make sure that our velocity as we go by the procs is not so fast that the procs pulse that the program sees is shorter than the read time of the program. we can make that pulse longer by making the target longer, for example, because we don't want to have to slow down just to accommodate the read rate of the program. So we could use a bigger piece of metal, and then the prox is on longer as we go by it. But we just need to make sure that that detail is accounted for in our engineering. And nevertheless, the point here is that that signal will go away, but we want to affect a permanent change that's not time related to the signal itself. And so we'll need to do some sort of latching logic or one shot in this program. I haven't solved that portion of the program yet, but that may be one of the tools that we use. So, your numeric functions are all your basic math, and we actually can do squares, absolute values, and powers. We have some trigonometric functions here, which is nice. I'm not sure if I'll have to get into trigonometric functions to calculate the proper stopping ramp or delay time on the run command based on the first and second method I referred to in the constant displacement decel challenge. We'll see. Here are the constants that we want to use, and notice that they're all in percentage, and this is the problem I referred to earlier with regards to dealing with whole numbers in this program. We're not going to do any communications in the challenge. We will deal with this later on, and I'm going to need to get somebody from the factory to deal with this section because I'm not real good at the comms. And control remote I/O. And here are the temp registers that we can use to store numbers for calculations in our programs that we can bring up later. So, for example, vel ratio. I'd probably store it in a temp register and then call it up and use it in a formula. The temp register will be updated as we're running along the conveyor so that the number will always be available to me, and therefore will be available to me when I hit the prox, and I'm going to need it to designate the new decel value in C104. So, the last thing is blank because that's where you can create objects that are combinations of the previous objects that I've gone over and put them into, we used to call it a macro, custom object, call it what you will, and they will be stored here. Now you can use that later on in other programs. So, that's the review that I intended, just to kind of get us back into the swing of things. I did want to apologize for having to go away for so long, but I had a very important family test that I had to deal with. And that's done, so I'm going to be around for quite a while, whether you like it or not. Now, with regards to the challenge, let me see if I can scroll down on this thing. I outlined some programming method requirements for method 1. I've already discussed a few of them with you, some of the challenges that I perceive, and then some programming requirements for method 2. I actually really like method 2 because it seems to me to be a little bit cleaner and more elegant, just running at the run command and dealing with a time-based delay versus a ratio and a new decel ramp. But we'll see as we get into the basic math of this thing. Now, this is kind of a difficult challenge. I was hoping that some of you might come up with some easier ones that we could do. Although if you have a more difficult one, by all means, bring it on. Because that's how we're really going to learn to become competent in this program. As I'm sure Kyle will attest, I mean, you can read all the documents and do all the practice exams that you want, but you really learn when you get out there and start doing something specific. And for example, this limitation on using whole numbers versus percentages in the program, we don't exactly tell you that that's a limitation in any of the documentation that you use in the training sessions. We pretty much let you explore that on your own and discover it. I'm not even sure if the original guys thought about that when they wrote the original program structure. So the other thing I wanted to let you know is that we have at Western Automation, I think it's 3 or 5, I can't remember, demo units that are the brainchild of Larry Fuson, the regional manager. And basically what they are is control boards that can be used to do actual application simulation. They will function as a drive. You can connect to it from your laptop with Drive Wizard or Drive Works Easy and do simulations. Make sure everything works from the control board standpoint before you go put it on a real drive. Now, these demo units have everything but the power section. So they're quite economical for us to produce. Larry's initial idea was modified by the factory, and instead of just a control board in a small box, which is the fully functional engineering way of doing it, somebody in marketing says, well, let's make it look like a drive. So they did. And instead of giving us a nice compact box, they sent out a small VFD without any guts in it. Still has the heat sink, still has all the plastic housings, etc. And initially we said, hey, you know, you made it bigger for us to carry around. But I actually like the idea because now I have a unit that not only doubles as a lab virtual drive, if you will, but can be used in any show or training that you might want to conduct for your customer base or for your staff engineers. And indeed, we're going to be using it for the first time at a show down south of the border to illustrate Drive Wizard and some of the other software tools. We're not going to be displaying Drive Works Easy at that show, but it's going to be on a tabletop demo in somebody's booth at a trade show down in, I'm not sure if it's Tijuana or Mexicali, someplace down there. So we didn't take up a lot of space. We have basically a screen, laptop, and one of these demo units, these Larry Fuson specials, and it's very effective. You really can get some people engaged, have conversations. You know, you're not just talking about a static demo here. It does draw people into the booth, and you can let them play around with it. So those tools are available to you. I will send out a picture of the unit to just remind you what we're talking about. This is something that I encourage you to take out, like a library book from us at Western Automation, so that you can do some work with your DriveWorks EZ applications. They are very economical to purchase. I'll get a price when I send it out to you, and you can get one for yourself. But if you really don't need the fancy version from Yaskawa, just use a control board and a power supply, because that's really all that it is. And that will allow you to do, if you will, virtual. I just got an email from Joe Gonzalez. Where's the price of the demo unit? I'll send that out to you, Joe, when I put a photograph out there of what it looks like. It's basically a half horsepower size drive. So, 11 inches high, I don't know, 7 inches deep and 4 or 5 inches wide. And I'll get that price to you. I don't know what it is off the top of my head, Joe. But again, just a great idea from Larry Fuson that got some enhancements from our marketing department. And by the way, while I'm on the subject of the Yaskawa marketing department, as a 30-plus year veteran to Yaskawa, I'm really not used to using the term marketing and Yaskawa in the same sentence, but I'm happy to be able to do so today. So just a little bit of an aside, we have a relatively active marketing group now. Josh Julius, the distribution manager, has been extremely active in it. He's been given great support by Jason, our business development guy, who reports directly to Mark Bernicke, who is the grand poobah of the drives division. Mark's been around forever, just like some of us. And we have hired a lady by the name of Nikki, who is a seasoned marketing person in the drives world. She actually, I think, still works out of Texas. And she has some really great experience. She used to work for a major drives distributor, not us, which is great because her experience now is not just Yaskawa. At Yaskawa, how can you have any experience in marketing? But what they've come up, if you remember that time challenge that they did for connecting the Yaskawa drive to the Allen Bradley PLC via Ethernet IP. And we put out dozens and dozens and dozens of videos onto the social media platforms. It turned out to be a rousing success. We got a lot of business from that. And basically what we were proving via video was that anybody, one of the guys had his 12-year-old daughter do it, and she connected the VFD, the Yaskawa GA500, to the Allen Bradley Compact Logix PLC via Ethernet IP. I think she did it in less than 2 minutes. So while I'm on this aside, Yaskawa's marketing department is getting pretty active. Please look for an announcement for the Yaskawa Blue Book. And that Blue Book is a special application that you can download that makes access to manuals and all sorts of technical data very simple and direct. It is, if you will, a very pointed entry into our website, makes things easier. Our website's a little bit difficult to navigate. The Blue Book is just sort of a handy little repository that you can customize yourself on your own account, and it'll be available to you soon. So, 3 significant achievements for the Yaskawa marketing group: the time challenge for connecting to Allen Bradley PLCs, this demo unit that I mentioned earlier, and the Blue Book. And you will be seeing more because this group is now pretty well funded. I'm very excited about it. I think it's going to do nothing but help our ability to sell. Again, while I'm on this side, somebody asked me to give you an update on the situation with regards to our deliveries, etc. And that is probably not as optimistic as I would like. We are having some pretty significant shortages in product. The delivery times on some units have gone out to 8 weeks. It's really what I'm seeing, the worst that I'm seeing. It was initially just on certain option boards because of the chip shortage. It has moved into some shortages on V1000s and A1000s, which, as you know, are legacy products, but we still use them, especially in areas where we're selling the A1000 with a case software option, such as spindle orient or high frequency, something that hasn't been released yet onto the GA800, GA500 platforms. We're working desperately hard to get those certified through our testing processes so that we can take those off the A1000s and further reduce our need for those legacy products. But as of right now, we're running into some shortages there, so just be aware. As far as GA800, GA500, I'm seeing 4 or 5 week delays where I'm used to always having something in inventory. When you have that problem, I cannot emphasize enough, please do not task your normal inside salesperson at the factory, like Lourdes or somebody like that, with the task of trying to expedite or find you something, because these poor inside salespeople are just barraged right now, as you can imagine. When you have a specific need, you need to contact us at Western Automation. Contact myself, Sasha, Eric, Glenn, Chris Omedian, Chad, Josh, Mike Thompson, the whole bunch, Todd Bryce, and of course, Yolanda Harville. Actually, I'd go to her first if I were you. But we have ways of getting things that the factory doesn't have available to them. And most specifically, we've had wonderful cooperation with our channel in terms of getting drives when we really need them. Now, this isn't going to happen for 10 drives. It's going to happen for 1 or maybe 2, where somebody who's willing to basically do us a favor. The reality of it is at this point in time, inventory is king, and people are making good money when they have invested and gotten the inventory. We tried to alert the channel early on when we saw this coming to stock up, get some stuff into the field so that you'd have it when you need to sell it. Right now it's a little late, but the fact is that inventory is king, and always is the case, and is even much more so now. So when you have a problem, we will try to find that unit for you. We will also look at all the alternatives. If it's a GA800, we'll see if we can do it with a GA500. Maybe we can find the odd A1000 to do it, one size up, all that stuff. Just the point is, refer that to us at Western Automation. Do not expect the factory inside salespeople to do that for you, because they just are too barraged at this point. So, thank you for that little aside to give you the updates. I will say in closing on that update that we're still in much better shape than what I'm seeing from competition. I mean, some of the Siemens and Delta stuff I'm seeing out 22 weeks. I'm not quite sure how they messed up that bad, but somebody's neck is on the line there. There are companies with significant shortages, and I will tell you that we at Yaskawa have been enjoying the fact that we make the stuff in the United States, we inventory at a high level, and we've got some doors open to us that have never been open to us before. In closing, I cannot recommend enough that you go out and call on customers that you just gave up hope on before, because even the most hardcore Allen Bradley guys are talking to us. And will they talk to us when Allen Bradley gets flush with their Delta drives again? Can't answer that question. I will say this, in my experience as a Yaskawa person that runs over 3 decades, once I get somebody on Yaskawa, I'm hard pressed to remember a time when I lost the business. So we'll leave it at that. Okay, so we've had a chance to get this class up and running again, review the DriveWorks EZ. We're going to move into some tough applications next week. Again, review the document that I've already sent you on this drive, the constant displacement D-cell. Understand the application, ask questions, so that you can be up to speed when we actually do this on the class, which we will try to start doing next week. I have to solve some technical issues with Danny's help first. I will also talk to Kyle, who I think is, again, one of our best DriveWorks Easy programmers in the group. And then I really want to work on some other applications that come from you. So please take a moment and think of something that you can send in. If I don't get too much of that, I've got some stuff to fill, but I really would prefer to have it come from you. So we're going to end this class a little bit early today. It's 7:54. That's about all I have to say on the class coming back. I want to thank you, and I'm really glad to see you all again. We will be at it again at 7 a.m. next week with a very heavy technical session on DriveWorks Easy, so be ready. Get your DriveWorks Easy Pro up on your computer, and it's 7:55. Time to go to work. Thank you very much. See you next week.
Thank you, Pierce.
Thanks, Pierce. Take care. Welcome back again.
Thank you very much. Bye now.